In the final desperate months of 1943, beneath a cold, unforgiving sky in the Reich's industrial heartland, there existed a paradox of modern warfare, a truth too enormous for even the keenest eye to observe. The place was Rechlin, or perhaps Lechfeld, where the German High Command had poured its last, most precious resources into the revolutionary promise of the jet age, the Messerschmitt Me Two-Sixty-Two. Yet, despite this qualitative leap, the war was already lost, mathematically foreclosed by an industrial power so vast it treated the raw materials of combat not as treasure to be conserved, but as ammunition to be expended. High above the overcast, watching the contrails stretch across the firmament, stood Major Erich Hartmann, the ace of aces, a man of uncanny skill and lethal precision. He had already achieved over 200 aerial victories, but as he gazed up at the emerging vapor trails, he saw not individual fighters, but the immense, relentless procession of the American heavy bomber fleets, the corpulent, unyielding B-17 Flying Fortresses and B-24 Liberators. And he was looking at the physical embodiment of the unanswerable question, quality versus quantity. The true conflict was one of resources. The German strategy was built on the meticulous, rationed efficiency of a fragile, finite ecosystem, relying entirely upon its precarious synthetic oil output and dwindling stockpiles of strategic metals. The American strategy, meanwhile, was predicated upon the crushing exponential arithmetic of abundance, the ability to draw upon billions of barrels of natural oil reserves and feed the assembly line with raw materials at a volume that turned the logistical challenge into a sheer exercise of physical force. Germany possessed the genius to invent the jet engine. America possessed the industrial capacity to nullify it, using the very concept of unlimited resources as the ultimate weapon. Hartmann, staring into the sky, was witnessing the mathematics of impotence play out in high altitude, a prelude to a defeat written not in tactics, but in the relentless, unforgiving ledger of global production. The central thesis of the entire conflict was now visible. The revolutionary technology of the jet was a magnificent work of art, but it was being brought to bear against an enemy who had turned the entire nation into a war factory. And in that exchange, the single, brilliant design would always yield to the crushing force of 10,000 mediocre ones. The genius that propelled the Me Two-Sixty-Two was not merely technological. It was a profound, almost desperate act of defiant creativity born from necessity. In the laboratories of Junkers and the drafting rooms of Willy Messerschmitt, the German engineers had solved the fundamental problem of internal combustion and sustained high-speed flight, giving birth to the Jumo Zero-Zero-Four axial flow engine. The moment a German pilot first pushed the throttle and felt the smooth, terrifying surge of pure jet thrust, the entire world of air combat changed irrevocably. This was the birth of the Wunderwaffe, the jet that promised to single-handedly sweep the skies clear of the encroaching Allied bomber stream. The sheer speed advantage was blinding. The Me Two-Sixty-Two could reach speeds well over 500 miles per hour, leaving the fastest piston-powered Allied fighters trailing helplessly in its wake, unable to close the distance or dictate the terms of the engagement. This led to the initial laughter of the elite, the supreme confidence that bordered on arrogance among the German fighter pilots. They looked down with outright derision at the heavy, robust, and seemingly clumsy American piston fighters. The P-47 Thunderbolt was dismissively dubbed the Flying Milk Bottle due to its corpulent fuselage, and the P-51 Mustang was often referred to with equal contempt. These conventional aircraft were seen as relics of an obsolete era, relics of an enemy too slow and too pedestrian to comprehend the future. Yet this visceral awe felt by the German pilots for their own jet's performance masked the fundamental, terminal reality that Willy Messerschmitt's conviction that speed alone was an insurmountable defense was tragically flawed. Speed could outrun the enemy, But speed could not solve the problem of mass production, nor could it replenish the fuel tank. The jet fighter, the finest piece of military technology the war had produced, was unknowingly stepping onto a battlefield governed not by aeronautical physics, but by the far simpler, crushing geometry of logistics, a geometry the German engineers had failed to factor into their calculations. The laughter was loud, but it was dangerously premature, a thin veneer of hubris covering a fatal unseen vulnerability. The true god of the Second World War was not forged in the blast furnace of technological genius, but in the relentless, automated, and brutal repetition of the assembly line. While Germany labored under the meticulous, highly skilled necessity of handcrafting its engines with scarce substitute materials, the United States was transforming an entire nation into a colossal pragmatic war factory, a force of production so vast it defied military analysis. This was the reality of the Allison Merlin Miracle, the unsung triumph of industrial scale that would ultimately render the Me Two-Sixty-Two irrelevant. Shift perspective away from the sleek, polished perfection of the German jet to the deafening, oily din of the Packard plant in Detroit, or the colossal Willow Run facility where bombers were being birthed like shoals of metal fish. The Packard-built Rolls-Royce Merlin engine and the Allison V-1710 were not engineering miracles. They were production miracles. The scale was truly overwhelming, designed to prove the thesis relentlessly. By 1944, American factories were turning out engines in numbers that reached into the tens of thousands, with airframe output following suit. Consider the sheer force of these precise, overwhelming data points. North American aviation was pushing out approximately 1,500 Mustangs per month, a logistical triumph of transforming a vast peacetime economy into a dedicated apparatus of destruction. This mass production ethos, unapologetic, brutal, and focused entirely on maximum output rather than meticulous perfection, stood in stark contrast to the meticulous, highly skilled German engineering culture. The true, unstoppable force was embodied not by a named general or ace, but by anonymous figures like Charles Sorensen, Ford's production genius, who represented the ability to transform steel, aluminum, and labor into an endless self-replenishing wave of aerial combat power. This capacity was the ultimate strategic weapon, the quiet, terrifying reality that mocked the German belief in qualitative superiority. The Allies were not fighting with better fighters. They were fighting with an exponentially larger number of reliable ones, and in the mathematics of defeat, the piston engine's simplicity and maintainability guaranteed a far longer service life and a far higher deployment rate than the Jumo Zero-Zero-Four could ever hope to achieve. The unsung iron god was industrial output, and it worshipped at the altar of quantity. If the German advantage was speed, the American counterargument was defined by volume of fire, a pragmatic and overwhelming dedication to saturation that rendered precision irrelevant. The battlefield was governed by the geometry of the kill, an axiom stating that overwhelming firepower, not surgical accuracy, was the true arbiter of success. Juxtapose the Germans' armament philosophy, epitomized by the 30mm Mk-108 cannon, a formidable weapon designed for efficiency and economy of ammunition, with the brute force of the American M2 50-caliber machine gun. The German approach, while elegant, resulted in a cripplingly meager ammunition load, often just 100 rounds per cannon, requiring a level of lethal precision that was often impossible in the chaos of aerial combat. The American fighter, whether the rugged P-47 Thunderbolt or the nimble P-51 Mustang, brought to bear a terrifying weight of fire, typically 6 or 8 synchronized M2 guns, each capable of firing at approximately 6,000 rounds per minute. This translates not into a surgical strike, but into an instantaneous avalanche of steel and lead. The moment for the statistical reveal confirms the staggering disparity. Where the German jet fired a cautious burst of 30mm shell, the American fighter unleashed literally thousands of rounds of heavy-caliber ammunition during a typical engagement. The American doctrine was not to aim for the pilot or a critical component. It was to saturate the target area until the aluminum airframe simply disintegrated under the immense, focused pressure of high-velocity mass. The German jet was designed to be a scalpel, fast and efficient, but it was forced to fight a continuous blizzard of 50-caliber fire, a blizzard generated by an industrial capacity that could afford to waste bullets. The fatal flaw was emerging. The Me Two-Sixty-Two was fundamentally outgunned, not in the caliber of its shell, but in the sheer volume of the metal it faced, a volume so great it mocked the very concept of evasion. The German jet offered revolutionary speed, but it offered no protection against the simple, brutal 50-caliber axiom of American war production. The revolutionary thrust of the Jumo Zero-Zero-Four engine harbored a fatal paradox at its very core, a devastating secret hidden within the throttle quadrant. While the jet delivered speeds that rewrote the laws of aerial combat, its power delivery was an exercise in agonizing fragility, its performance dictated by the unforgiving thermodynamic and metallurgical constraints of a first-generation axial flow turbojet. This was the jet's Achilles heel. The engine was acutely vulnerable to rapid changes in fuel input. A sudden panicked shove of the throttle, the instinctual maneuver of any pilot attempting to escape a dangerous situation, would immediately lead to a disastrous compressor stall, causing the engine to violently seize, or, even worse, result in turbine overtemperature, melting the brittle, substitute alloy blades and causing catastrophic engine failure. This vulnerability forced the German pilot to fly with a crippling, almost ceremonial throttle caution, requiring delicate, agonizingly slow adjustments to power settings that utterly negated the jet's combat flexibility. Juxtapose this against the experience of the anonymous American pilot in his P-51 Mustang, powered by the robust, reliable Packard-built Merlin. He could slam the throttle forward, dive, climb, and maneuver violently, relying on the immense, forgiving nature of the piston engine and its supercharger. The German pilot had the speed, but his power was fragile, a crippling tactical constraint that made the fastest fighter in the world the least maneuverable under pressure. The ironic scenario was complete. The machine designed to grant maximum tactical freedom imposed the maximum psychological and physical constraint upon its operator. That hidden design flaw, the simple fact that the most sophisticated engine in the world could be destroyed by a clumsy hand, meant the jet's operational performance was not dictated by the limits of engineering, but by the limits of human composure and fatigue. The German pilot was forced to fly with the delicacy of a jeweler, knowing that his engine held the secret to his own demise, a final, terminal technical flaw that stripped the jet of its most crucial wartime asset, the ability to react instantly to mortal danger. The truth of the Me Two-Sixty-Two's tactical downfall was not decided at 50,000 feet during a blindingly fast dogfight, but in the slow, vulnerable moments when it had to obey the inescapable law of gravity. This key realization formed the midpoint climax of the jet war, a pivotal human event that proved the thesis. Speed is useless if you cannot land. The scene shifts to a jet base, perhaps Lechfeld, during the crucial 6 weeks of the late summer of 1944. German pilots, after their exhilarating but constrained high-speed sorties, faced their greatest peril. The moment of approach, when the jet was below 150 knots and operating precariously close to the stall speed, demanding the crippling ceremonial caution of the fragile throttle. American intelligence, led by sharp minds like Colonel Hubert Zemke, commander of a P-47 group, saw this pattern not as a vulnerability, but as an opportunity for annihilation. Zemke issued a deadly simple order that redefined the air war. Ignore the jets in the air, kill them when they are landing or taking off. This was a strategic masterpiece of industrial pragmatism. Why risk a costly, difficult, high-speed engagement when you could simply ambush a priceless, irreplaceable enemy asset when it was at its slowest, most constrained, and least defensible moment? The ensuing ground attacks turned the advanced airfield into a killing field. The P-47 Thunderbolt, the rugged flying milk bottle, once derided for its corpulence, proved to be an ideal ground attack platform, shrugging off light anti-aircraft fire and delivering its devastating avalanche of steel and lead with ruthless efficiency. The visceral, sensory descriptions of the attacks were terrifying. The roar of the Packard-built Merlin, the thunderclap of the cannon shells, and the sight of the revolutionary jets being transformed into smoking debris on the runway. This was war waged with hammers from heaven. The jet's revolutionary speed was utterly nullified by the inescapable need to obey gravity, its technical brilliance undone by a simple, deadly tactical countermove. The Me Two-Sixty-Two was not defeated by a faster plane. It was defeated by the decision to turn its necessary vulnerabilities into an execution ritual, a final tragic proof that the ultimate factor in victory was not technology but operational sustainability. The true nature of the Allied strategic campaign was not focused on airframes, but on the molecular components of propulsion, an unapologetic military business history dictated by the Logistics of Annihilation. The Allies, primarily the U.S. 8th Air Force and the RAF Bomber Command, did not seek to destroy the Me Two-Sixty-Two on the production floor, which would only lead to dispersed temporary victory. They focused on the fuel supply, the single point of failure for the entire German war machine, relentlessly repeating the key concept of industrial capacity. The campaign became a sustained, methodical, and devastating attack designed to erase the very ability of the Reich to wage war. The targets were the colossal, highly complex synthetic oil plants, industrial cathedrals at Leuna and Pölitz, that were responsible for providing the vast majority of the high-octane fuel and diesel necessary for the jet engines and the Wehrmacht's entire logistical system. This was the core conflict, the unlimited American resources versus the delicate German supply chain. The Allies drew from the unending barrel of Texas and Oklahoma, shipping billions of gallons of natural oil. The Germans relied on the fragile, high-pressure chemistry of turning coal into fuel. When the air attacks turned those synthetic plants into twisted, irreparable wreckage, the supply line did not merely shrink, it began to dry up entirely. The irony was profound. The German jet was too fuel-thirsty to be effective, its scarcity becoming a direct function of Allied abundance. When the fuel dried up, the world's most advanced fighter, the Me Two-Sixty-Two, became nothing more than a magnificent, complex piece of useless aluminum, permanently grounded and awaiting the inevitable. The strategic decision to focus on oil proved that the jet was not beaten by superior technology, but by superior logistics. The fuel crisis was the ultimate, unanswerable expression of the mathematics of defeat, a final judgment that rendered the qualitative leap void. The war's ultimate cost was measured not in hardware, but in the slow, agonizing depletion of the individual human spirit. By 1944, the conflict had shifted to a tense and somber emotional tone, experienced acutely through the pilot's wager. The ace of aces, Major Erich Hartmann, now found himself strapping into whatever aircraft was fueled and available, a desperate late-war piston fighter, or the perpetually scarce jet, facing an enemy that seemed to multiply infinitely, their resilience ensured by the endless rotation and fresh equipment pouring from the American factory floor. The German pilot was forced to fly multiple times a day on meager rations, nursing a fragile engine built with substitute alloys, and watching a fuel gauge that guaranteed only minutes of effective combat. He was fighting a psychological battle against the absolute certainty of futility and the ever-present knowledge that every piece of lost equipment was irreparable. Contrast this grim reality with the anonymous American pilot's experience. Though facing genuine danger, he was part of an infinite stream, knowing that his replacement and his brand-new P-51 was already rolling off the North American assembly line. This resilience was a direct calculated function of industrial capacity. The German pilot was an invaluable expert worn down by attrition. The American was an easily replaced cog in an unstoppable machine. This immense psychological fatigue became a terminal military weakness, directly amplifying the jet engine's fragile throttle. Design. The exhausted, stressed pilot, responding instinctively to an immediate threat, was statistically certain to make a clumsy, rapid throttle movement, the exact action that triggered the catastrophic compressor stall. The rising accident rate was often not caused by enemy fire, but by human fatigue intersecting with technical fragility. As one German pilot lamented, speaking to the ultimate futility of the fight, "They weren't fighting us, they were fighting the clock and the American factory." The Me Two-Sixty-Two, the world's most advanced fighter, was not shot down. It was grounded by exhaustion, its design constraints cruelly exposed by the simple demands of sustained human effort. The deepest, most fundamental design flaw that doomed the German jet was not in the throttle, the fuel, or the tactics. It was a lack of access to simple, high-performance elements, a brutal consequence of the ultimate scarcity dictated by the global balance of raw materials. The genius of the Jumo Zero-Zero-Four axial flow turbojet was simultaneously its own terminal weakness, demanding materials of uncompromising strength and heat resistance for its critical turbine blades, materials rich in nickel and chromium. These strategic metals were the currency of sustained high-temperature flight, and they were metals Germany had practically none of, having been blockaded and resource-starved for years. This forced the German engineers into the metallurgy of necessity, compelling them to use inferior substitutes that fundamentally determined the short lifespan and fragility of the engine. While a robust American piston engine could be expected to last up to 800 hours between major overhauls, the revolutionary Jumo Zero-Zero-Four, compromised by the copper and chrome deficit, was limited to a staggering mere 10 to 25 hours of flight time before the turbine blades failed catastrophically due to thermal stress and fatigue. This chilling statistical reveal meant that the German production line was trapped in a self-consuming cycle. For every hour a jet was in the air, a replacement engine had to be built, turning the manufacturing effort into a production of attrition against its own inventory, rather than sustained readiness against the enemy. The scarcity of raw materials predetermined a short service life, making the Me Two-Sixty-Two, for all its revolutionary promise, a tragic logistical nightmare. The flaw wasn't an engineering oversight, it was an unavoidable geopolitical reality. The jet was defeated not by superior aerodynamics or tactics, but by the fact that the United States controlled the global supply of high-temperature alloys, meaning the German fighter was designed to fail from the moment its brittle, substitute turbine blades first spun up to speed. The final judgment rendered by the brutal calculus of World War II was not one of qualitative genius versus conventional thinking, but rather a cold, unforgiving verdict delivered by the unmistakable mathematics of the ledger. The German qualitative leap, the magnificent, silent silver promise of the Me Two-Sixty-Two, was revealed to be cosmically insignificant when weighed against the sheer industrial capacity of the United States. It was the ultimate irony, the final crushing defeat, where innovation was checkmated by infrastructure, and the brilliant scientist was ultimately defeated by the anonymous foreman on the assembly line. The Me Two-Sixty-Two, for all its revolutionary potential, was never truly a military aircraft. It was a philosophical statement, a piece of terminal technology that proved one immutable truth. The power to invent a superior weapon is meaningless without the unlimited capacity to mass-produce, sustain, and fuel it. The final, overwhelming numbers illustrate this truth with a chilling, definitive finality, demonstrating how the war ceased being a test of courage and became a test of resource management. Consider the stark statistical reveal that settles the debate forever. The total number of Me Two-Sixty-Two jet airframes produced by German factories throughout the entirety of the conflict hovered around 1,400, a number that includes prototypes, trainers, and aircraft destroyed before they ever flew in combat. This meager output was further diminished by the relentless attrition of engine failure and the methodical, targeted air attacks of Colonel Hubert Zemke's group, meaning the total number of operational sorties remained pathetically low. Juxtapose this finite, fragile number against the tidal wave of Allied production. The P-47 Thunderbolt, the flying milk bottle, once mocked by the elite, was produced in numbers exceeding 13,000 units. The sleek P-51 Mustang, the machine that truly conquered the European sky, rolled off the North American assembly lines in numbers approaching 15,000. The German technological miracle produced an artifact of scarcity. The American factory produced an avalanche of steel and lead in the tens of thousands, ensuring that for every single German jet, there were 20 American piston fighters waiting to destroy it, or waiting to destroy its fuel supply, or waiting to destroy its pilot. The Me Two-Sixty-Two was not defeated by a single factor, but was strangled by the simultaneous converging consequences of its own design and the resource poverty of the Reich. Its insatiable fuel appetite, requiring synthetic aviation fluid, directly invited the Allied strategic bombing campaign that crippled the Leuna and Pölitz plants, grounding the force before it could even muster. The engine's structural integrity, the core requirement for sustained combat, was perpetually compromised by the nickel and chromium deficit, forcing the use of inferior alloys that limited its lifespan to a catastrophic 10 to 25 hours of flight time. This was the metallurgy of necessity at work, turning a revolutionary weapon into a logistical liability that consumed more effort replacing engines than fighting the enemy. The genius of the German engineers had solved the complex problem of jet propulsion and sustained high-speed flight, but they failed utterly to solve the simpler, more brutal problem of mass production and unlimited logistics. The final lesson of the jet war is that technology is subordinate to the industrial assembly line. The Me Two-Sixty-Two was never truly defeated in a glorious aerial duel. It was defeated on the production floor, suffocated by its own fragility, and finally obliterated by the American decision to wage a war of unending barrels of oil and an avalanche of bunked 50-caliber ammunition. It was a victory of the mundane over the magnificent, a final, cold recognition that in the grand theater of modern warfare, the true unsung Iron God is not the brilliant designer, but the inexhaustible factory that can churn out 10,000 of the enemy's best attempts. The final Unforgiving Ledger confirmed that Germany had lost the war not in the skies over Berlin, but in the oil fields of Texas and the vast, tireless factories of the American Midwest.